Good morning, children. Today we'll learn this topic, measures of dispersion. It is chapter 8 of maths paper 2A, second year. So this is a topic which deals with statistics. So in your lower classes you studied about collection of data and then forming the frequency distribution table. You will have class intervals, frequency. You know the how to write this frequency distribution table, how to construct this frequency distribution table, and then you have learned the measures of central tendency. You have learned the measures of central tendency. What are these measures of central? What do you mean by this measures of central tendency? You will find the average, like you have learned this mean, median, mode, geometric mean. Many more are there, but I think you have learned only these three. So these give you the middlemost value of the given data points. So what is the centered value, measures of central tendency, how the data are centered about one value. So one single value represents the whole data points. So that is what is the measures of central tendency. Now, like for example, suppose I take these numbers 6, 60 and 90. What is the mean of this? 6 plus 60 plus 90 is equal to 156. So the mean is 156 by 3, that is 52. So the mean of these three numbers is 52. And if you take 51, 52, 53, for this also the mean is 52. So can you say that this data and this data are almost the same? No, because here there is a lot of variation between the values. Here they are all nearer to, the three values are nearer to 52. This data is not scattered, but here the data is scattered. They are far away from this middle value, central tendency value. So that means here we cannot say how the in this actually we cannot say from these measures of central tendency, we cannot say that how the data is scattered, how the data is spread around the center value. So for that reason, we need these measures of dispersion. What are these measures of dispersion? They give you how the data is scattered around the central value. Like for example, suppose you have this data 28. Suppose that these are the scores. These are the scores run by two batsmen. 28, 70, 30. 42 and then 64, 80, 93, 5 and 116. Now when you take the average of it, now when you take the mean of it, there are 10 values. So 530 by 10 becomes 53. So the mean of this distribution, this raw data is 53. Now the scores run by another batsman B are given like this: 44, 38, 60, 45, 52, 54, 49, 54, 76, 58. Now, when you add them, this is also 530 and the mean for this is also 53. So, when you see the runs scored by A and the runs scored by B, here you can see that he has the least value as 2 and the greatest value as 116. Whereas for him, the least value is 38 and the greatest value is 76. So here there is a lot of variation in the runs scored by A than the runs scored by B. So how we can say that the player B is more consistent. He is more consistent than the player A, because his values, his runs scored are more scattered. So for that reason, we need these measures of dispersion. So what are these measures of, to understand how the data is scattered around the center value, we need these measures of dispersion. In these measures of dispersion, we have three measures: range. First one is range. Second one is mean deviation. And the third one is variance. We have variance, and then fourth one is standard deviation. These many more are there, but you have only these four in your syllabus. Now these two are deleted, and you have only range and mean deviation. Now what is this range? Range is, suppose you are given a raw data, like suppose you are given the raw data. We'll take these runs only: 28, 70, 32, like this. Okay. Now first four added, and suppose that you have, okay, only these four will take. Now what is the range of this data? This is the raw data. For ungrouped data or raw data given like this, what is the range? The range is just maximum value minus minimum value. That is 70 minus 2. 70 minus 2 is 68. This is how we find the range. Now we have another kind of data. This is just ungrouped data or raw data. We also have excise and FIs, mid values, frequency table, like this. In this case, you may have some values like 5 and then 25, 5 for frequency, it may be some 3, here it is some 2, and 20, it is 1, and then 15, it may be, or 18, any numbers, it need not be multiples of 5. 18, it is 4, like this. Suppose I have a distribution table like this, where xi and fi are given. Then in this case, the range is defined. Range is equal to the maximum of excise. These are all excise. This is x1, x2, x3, x4, like that. Raw data are denoted by excise. These are excise. So here xi value is 5. So this actually, this data means that when you write in the raw data form, it is like this: 5, 5, 5, 25, 25, and then 20, and then 18, 4 times. So this data means this. Now what is the minimum value? 5. Maximum value is 25. So the range is 25 minus 5. So like this we find the range for a group data like this, which is in the form of xi and fi. Now suppose you have class interval and then frequency like this. Suppose the data is a group data like this. Like suppose 40 to 50, it is some 5, and then 50. These are class intervals. This is lower limit and this is upper limit of the first class, like that. 50 to 60, some 8, 60 to 70, some 4. Suppose you have something like this. Then the range of this data, frequency distribution table is the upper limit of the largest class. This is the largest class. The upper limit of the largest class, that is 70, minus lower limit of the smallest class. Lower limit of the smallest class is 40. So 70 minus 40, that is 30. So like this we find the range for a grouped data. So range for an ungrouped data is maximum value minus minimum value. Range for a grouped data is the upper limit of the largest class minus lower limit of the smallest class. So like that we find the range. Now mean deviation. Mean deviation also you have only for ungrouped data in your syllabus for this academic year. For grouped data and all, it is deleted. So how to find the mean deviation? The mean deviation is there are two kinds here. Mean deviation about the mean. Mean deviation about mean, and then mean deviation about median. So the mean deviation about mean is given by 1 by n into sigma of mod of xi minus mean. Xi minus mean. The mean deviation about median is 1 by n into sigma of mod xi minus median. Xi minus median. When it is about median, you must write minus median like this. So how to find this mean deviation about mean? Suppose you are given a data as 5, 4, 3, 6, 8 like this. With 5 values you are given. So these are your xi's. So then what you do? You find x bar mean. Mean, how many values are there? 5 values. So n is equal to 5. Now find x bar mean. Mean is just the average. 5 plus 4 plus 3 plus 6 plus 8 by 5 n. So simplify. You will get xi. 12, 20, 26. 26 by 5. 26. I'll take this instead of 8. I'll take it as 7. 7 like this. Then so it is 25 by 5. That is 5. Then what you do? Find mod of xi minus x bar. Sigma of, that is mod of 5 minus 5 plus 4 minus 5. Mod of 4 minus 5 plus mod of 3 minus 5 plus mod of 6 minus 5 plus mod of 7 minus 5. So write all the positive values only. So that gives you the sigma value. Then just substitute in the formula. Like that we do the, if we find the mean deviation about mean. In the same manner, we'll first find the median and then we'll take the deviations. These are called as deviations about mean. These are all deviations about the mean. Next, we'll find the deviations about the median. That's all. So this is all you learn in this chapter. Now we'll write the definitions. Yes, now we'll just write down all the points. A measure of dispersion or variation describes the spread or scattering of the individual data. Scattering of the data points around the central value. So the different measures of dispersion that you have are range, mean deviation, variance, standard deviation. Many more are there, but only you have these 4 in your syllabus. But now this variance, standard deviation are deleted for this academic year. Now this definition is very important, range, and then this formula, mean deviation from the mean deviation from the median of n observations is given by the formula 1 by n into modulus. It is the absolute value, positive value here. So these formulae and these two definitions are very important. So for an ungrouped data, range is defined as the difference between the maximum value and the minimum value. You can write greatest value and the smallest value also. And then for a grouped data, that is when it is given in the form of a frequency distribution table with class intervals and frequency. Then range is the difference between the upper limit of the largest class minus lower limit of the difference between upper limit of largest class and lower limit of smallest class. So these are merits and demerits. Merit is only range is easy to calculate. Just greatest value minus smallest value is easy to calculate, but it will not give you the how the data is scattered around the center value. It cannot explain any of such things. And then it does not tell us about the dispersion, scatteredness of the data from a measure of central tendency. Okay, now we'll do the problems. Now we'll find the range. We'll find the range for 3 kinds of data. Find the range of, suppose the question is find the range of some points like we'll take 3, 9, 8, 25, 46, 22 like this. Okay, so the solution is you are given x's. These are the x's: 3, 9, 8, some 25, some 46, 22 like this. So range is equal to greatest value minus smallest value. Greatest value minus smallest value. So what is the greatest value? Greatest is 46. So 46 minus smallest value is 3. That's all, 43. This is the range. Okay, now find the range of, suppose you are given a problem like this. Find the range of the following data. Range of the following data. Suppose the data is given as xi and then fi like this. Suppose you are given 20, 3, 18, 2, and then 22, 5, 16, 22 I'll take 1, 16 I'll take 2. Only 4 data. So actually what is this data? So in the solution we'll write. So given data is, so the given data you can write in the form of raw data like this. 20 is repeated 3 times. So 20, 20, 20. And then 18 2 times. 18, 18 2 times. Next 22 1 time. 22 1 time. 16 2 times. 16, 16. So this is your raw data now, given data. So now the range is equal to, like in this problem, how you have done, same way. Range is equal to greatest value minus smallest value. Greatest value minus smallest value. So what is the greatest value? Greatest value is 22. 22 minus the smallest value is 16. 16. So 6. 6. So this is your answer. Range is like this. So like this we find the range. Now suppose your question is find the range of some interval, class interval frequency we take. Range of the following data. Find the range of the following data. So suppose you are given class intervals and then frequency. Some example data. Class interval and frequency. Suppose it is 40 to 50. Some 5. Frequency is 5. And then 50 to 60. Some 7, like this. Then 60 to 70. 4. And then the 70 to 80. 2. 80 to 90. Some 5. Okay, suppose you are given a table like this. So find the range of the following data. So your solution is range is equal to upper limit of largest class. Upper limit of largest class. Upper limit of largest class minus upper limit of largest class minus lower limit of lower limit of upper limit of largest class minus lower limit of smallest class. So what is the upper, this is the largest class 80 to 90. What is the upper limit? 90. So 90 minus lower limit of smallest class. This is the smallest class. What is the lower limit? 40. So 90 minus 40. 50. That's all. So this is how you find the range for these 3 kinds of data given. Okay. So like this we do. Next problem is find the mean deviation about the mean. Next question, 4th problem. Find the mean deviation. Find the mean deviation about the mean for the following data. For the following data. Okay, 3 bits are there. 38, 70, 48, 40, 42, 55, 63, 46, 54, 44. 38, 70, 48, 40, 42, 55, 63, 46, 54, 44. Yes. Now second bit. 3, 6, 10, 4, 9, 10. Yes. Next third bit. 6, 7, 10, 12, 13, 4, 12, 16. Now for this the answer is 3.25. For the second bit the answer is 2.67. First one answer is 8.4. Now we'll do the first problem. Second and third you can take it as homework. First one, solution. First one. So you are given xi values. Xi's, what are xi's? 38, 70, 48, 40, 42, 55, 63, 46, 54, and then 44. Now you write like this. Write in the form of a table like this. Xi. 38, 40. 46, 54, 44. Now add them. You will get sigma xi. $500. So sigma xi is 500. Now we'll find the mean. Mean is equal to sigma xi by n. So how many values are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. N is equal to number of observations. N is number of observations. That is equal to 10. N is equal to number of observations is equal to 10. So therefore mean is equal to sigma xi by n. So what is sigma xi? 500. So 500 by 10. That is 50. So mean is 50. Now you write mod of xi minus mean. Xi minus mean. That means it is xi minus 50. So 38 minus 50 modulus. And here it is 70 minus 50. And here 48 minus 50. So this is 40 minus 50. 42 minus 50. So like this you find out 38 minus 50. 38. This is 12. This is 20. This is 2. Even if it is negative, you should write the positive value, absolute value. So this is minus 10, but you should write 10. This is 8. And here 55 minus 50. That is 5. And then 63 minus 50. 13. And then 46 minus 50. 4. And this is 54 minus 50. That is 4. And then 44 minus 50. That is 6. Now add them. You will get sigma of mod of xi minus x bar. Xi minus mean. X bar is mean. Okay, mean. Add them. So how much is it? 8, 9, 10, 11, 20, 34. 3, 4, 5, 6, and 8. 84. You get 84. Yes, 84. So now you'll write, therefore, mean deviation. So mean deviation about mean is equal to sigma of mod 1 by n sigma of mod xi minus mean. I is from 1 to 10. There are 10 values here. This is x1, x1, x2, x3, x4, like that, x10. So this is 1 by 10 into 84 is equal to 8.4. So like this you do the problem. You can try the remaining 2 problems. Okay. Now next one. Mean deviation about the median. Mean deviation about the median for the following data. So first bit 13, 17, 16, 11, 13, 10, 16, 11, 18, 12, 17. For this the answer is 2.45. Now next is 4, 6, 9, 3, 10, 13, 2. So for this the answer is 3.29. Okay, next problem 4, 6, 7, 10, 12, 12, 13, 16. So for this the answer is 3.25. Now we'll do the first bit. Okay, first bit solution. So what is the given data? Given data is xi is equal to xi's are 13, 17, 16, 11, 13, 10, 16, 11, 18, 12 and then 17. Now to find the median you must write them in ascending order. So the xi's in ascending order are xi's in ascending order. So what is ascending order? So the least one is 11. 11 is over. Next 12. 11, 2 11s are there. Next 12. Next, no, first you have 10. 10, 11 2 times and then 12. Next 13, 2 13s. Next 16, 2 16s. Next 17s. Next 18. 2 17s and then 2 18. Okay. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 observations. There are n is equal to 11 observations. So we'll find the median. Median is equal to middlemost value. So what is the middle value? Middle value is 1, 2, 3, 4, 5 and here 5. So 13. Middle value is 13. That is 13. Okay, now find mod of sigma of mod of xi minus median. That is equal to mod of 13 minus 13 plus 13 minus 17 plus 13 minus 16 plus 13 minus 11 then again plus 13 minus 13 plus 13 minus 10 plus 13 minus 16 plus 13 minus 11 plus 13 minus 18 plus 13 minus 12 plus 13 minus 17. So you just write all the values. This is 0 and then 4. This is 3, 2, 0, 3 and then this is 3, 2, 5, 1, 4. So the value is 4, 5, 6, 7, 8, 9, 17, 18, 19, 20, 22, 27. So this is 27. Now we'll write therefore mean deviation about median is equal to. So therefore mean deviation about median is equal to 1 by n into sigma of mod of xi minus median. So how much is it? 1 by 11 into so the sum of all this is 27. So it is So it is 2.45. You can calculate, simplify. This is the answer. Now the next problem, second bit is similar to the first one, you can try. Now in the third bit, you are given only 8 observations. So when there are even number of observations, when there are odd number of observations, median is the middlemost value. Now when there are odd number of even number of observations, 8 observations, when it is odd number of observations, then middle value is the median. When you have even number of observations, you must take the average of the two middle values. So middle values are 10 and 12. So the average is 11. So median is 11. Now like in earlier problem, you find out sigma of. Sigma is over I here. Sigma is over I. I is from 1 to 8 values. So mod of xi minus median. Like in the earlier problem, you find out you got 26. So the mean deviation about median is 1 by n into sigma I from 1 to 8. So write the formula, find out like this. Now the next is minimal property of the median. You just learn this definition. So when you find the mean deviation from the median for any ungrouped data, that will be the least value. When you take the mean deviation about any other value, like mean deviation about mean or mode and all, there will be more than the mean deviation about mean. So this gives you the exact idea about the given data. So this property of mean deviation about mean is called as about median is called as a minimal property of the median. That's all. With this we completed this chapter. The rest of the topics are all deleted. Thank you.